Okay, 16.1, using graphs and properties to solve equations with exponents. So there are a couple of different ways that you can approach this, and I'm going to take this first page here to kind of address that. One way to do this is you can do it algebraically, and that's what we're going to look at in this particular case, doing the year term problems. But another way to do it is you can use your calculator and use the table to kind of help you solve. So if you have an equation, if you want to know where it's equal to 96, then you put this equation in for y1, go to your table and find to where it's 96. Now, one of the issues there is the fact that, what if it's not an exact value like 2 or 3 or something like that? Then it's not going to show up on the table. But that's another way you could do it. Another way that's possible is to graph the function here as y1, graph this as y2, and find their intersection. So you have a horizontal line, then you have your exponential going up, and then you find the point where they intersect. Okay, so we'll address this in class as we do this particular lesson, but I'm going to focus on the algebraic method of doing this, and then we'll talk through using the calculator. To these first year term problems, 6 and 7. So algebraically, to do this, you want to get the same base value. So basically you're trying to isolate x, but it's in a different way. So we take the 2/3, 3 to the x power equals 18. So the first thing I need to do is get rid of the 2/3. How do I do that? I multiply by the reciprocal. So let's cancel. So then I'm left with 3 to the x power equals, okay, now if I simplify this, that's 1. That'll go into that 9. 9 times 3 is 27. But I want to get it with the same base. So what that means is I'm thinking of 27 as a base of 3. 3 to the what power? Well, that's 3 to the third power gives me 27. 3 times 3 is 9 times another 3 is 27. So what's that mean? That means x is 3. Okay, so that's our solution. X equals 3. Okay. Now, again, what we could have done is we could have gone to our calculator and in y1 put our original exponential equation, then go to our table, go to x, y1, we know it's an increasing function, so if you start like at 0, if you plug 0 in there, you're going to get 2/3. If you plug 1, you're going to get 2. If you plug 2, you're going to get 6. Then if you do 3, you're going to end up with 18, which is what you wanted to find. You wanted to find where it was equal to 18, and that's at 3. And then the last method is if you want to do it graphically instead of using the table, you take 18, you plug that in again for y2, then you go to your graph, and then go to second, trace button, go to intersect, which I think is number 5, and then find the intersection, which would be at x equals 3 and y equals 18. But again, if you're going to use the graphing method, you've got to set your window where you see the point of intersection, okay? So if you can't see the point of intersection, change your window until that happens. All right, let's go ahead and go to problem number 7, and we'll do it algebraically too. Now again, you have these other methods with the table or graphically on the calculator, but we'll do it algebraically. So first thing we're going to do, get rid of the 3/2. So we multiply both sides by 2/3. So those all cancel. So now I'm left with 4/3 to the x equals 16/9. But you want to get it as a base of 4/3. Okay? So 4 what? 4 squared is 16. 3 squared is 9, so really that's 4/3 squared. Again, 4 squared is 16, 3 squared is 9, which means x is 2. So that's how we do it algebraically. But again, we have alternative methods. Use the calculator table, which is good if the answer is an integer, or use the graphing method and find their intersection. Okay, let's continue on. Let's word problem here. So 2 pages over, I'm going to do problem number 8. There are 225 wolves in a state park. The population is increasing. Now this is important. Increasing at the rate of 15% per year. You want to make a prediction for how long it will take the population to reach 500. Okay, so think about our basic exponential function. Y equals a times b to the x, where a is what? Our starting value or our zero term. So in this case, 225 times b. What is b? b is our rate. Now, because this says it is increasing, that means our b is something bigger than 1. So it's 1 plus something. Now what's that plus? It's the 15%, but we don't put a percent, we put a decimal. So if we do that, 1 plus 0.15 is 1.15. So if it ever says increasing as an exponential, then that b has to be something bigger than 1. Then what do we want to do? We want that to equal what? 500. That's our goal. So how would you do this one? Okay, so again, this is one of those situations where you got to be careful about what kind of answer. So in this case, I'm going to use the calculator, and I'm going to put this all as y1, and I'm going to put 500 as y2. Okay, so I'm going to type that in real quick. So I got 225 parenthesis 1.15 raised to the x. For y2, I have 500. Okay, then I'm going to set my window. Now, I have no idea where this is going to occur, but what I do know is it's got to be a positive answer, because x here is representing years. So I'm going to make my x min be 0. Let's say x max is 20, because I don't know what the answer is, but we'll just say 20. Y min, I know I'm trying to get it equal to 500. So let's just go something between that. So let's say y min is 490, y max is 510. Okay, then press graph. So what I should see is I should see my exponential going up, and then I should see a horizontal line coming across, and there's my intersection. So I go to second trace, number 5, and then press enter 3 times. And I get a decimal number. So this is usually the case for a word problem. So in this one, I get x is approximately 5.713 blah blah blah. So it says you want to make a prediction for how long it will take the population to reach 500. It would be approximately 6 years if you're rounding, okay, by years. Or you could be more specific and say 5.7 years. That's just going to be based on how the directions lead you to write your answer. Okay, let's go ahead and go to the next word problem. Alright, so there are 175 deer in a state park. So that's what we start with. The population is increasing. So that's going to be 1.12. We're adding it to 1 because we know it's got to be greater than 1 since it's increasing. And you want to know when it reaches 300. Okay, so this time, I'm again going to put that in my calculator. So I have 175 times 1.12 raised to the x, and then y2 is 300. Go to my window, leave my x's basically the same, okay? So I'm going to write it down this time. X min, 0. X max, 20. Your scale, you could do 1 or 2, it doesn't matter. Now, y min, okay, again, I want it equal to 300. So I'm going to make y min be 290. And let's make y max be 310. That way 300's right there in the middle. So whenever I do this, I've got to set my window up based on the criteria of the problem. Okay, press graph. My exponential going up, and then I should have a horizontal line coming across. Then I go to, again, second trace, number 5, press enter 3 times. And this time I get x is 4.76 rounded years. So again, you would say approximately 5 years for it to reach that population. So solving different methods to solve. Obviously with these word problems and huge numbers, algebraically is not the way to go. Use your calculator for that.